In this video I'm going to look at question 9 of the June 2010 Edexcel FP1 paper. The topic of the question is proof. The question starts by asking us to prove by induction a standard formula that sigma r squared from r equals 1 to n is equal to 1/6 n, n plus 1 to n plus 1. In the second part of the question, we're asked to use results for sigma r and sigma r squared to show that the sum of r plus 2 multiplied by r plus 3 from r equals 1 to n is given by 1/3 n, n squared plus a n plus b, where we need to find the values of a and b. And then in part C, following on from b, we're asked to show that a particular part of that summation from r equals n plus 1 up to 2n is equal to 1/3 n and then 7n squared plus 27n plus 26. With proof by induction, you must follow a standard steps. The first one is to take when n equals 1 and show that the formula is true. So looking at the left hand side, sigma r equals 1 to 1 of r squared is obviously just equal to 1. And on the right hand side we have 1/6 multiplied by 1 multiplied by 1 plus 1 and then 2 times 1 plus 1, and that's also equal to 1. So it's true for n equal to 1. Having done that, we assume it's true for n equal to k, or in other words, that we can put the value k into there, that the sum from 1 up to k is equal to 1/6 k, k plus 1, 2k plus 1. And from that we need to find the sum from r equals 1 to k plus 1 of r squared. Well, that must be equal to the sum from 1 up to k of r squared, which is the one that the formula that we're assuming to be true, plus the next term, which is k plus 1 all squared. So substituting the formula we're assuming to be true, 1/6 k, k plus 1, and then 2k plus 1, and then adding to that the next term, k plus 1 all squared. Now at this stage it's always advisable to factorize as much as you can. Always take out the fraction, if there is one, 1/6 in this case, and then the factors that are in both terms here. Well, in this case it's only k plus 1, so looking at what's left, the 1/6 has gone, so we've then got k multiplied by 2k plus 1, and then we've taken 1/6 out, so this gives 6 times, because 1 here is 6/6, so we've got 6 multiplied by, and then there's a factor k plus 1. Well, the next line then we need to multiply out the large bracket, so we've got 1/6 k plus 1, and then in the bracket it's a quadratic, 2k squared plus 7k plus 6. This will factorize, so we get 1/6 k plus 1, and it factorizes to be k plus 2 and 2k plus 3. Now we need to write this in the form of the original equation with k plus 1, so we get 1/6 k plus 1, and then k plus 1 plus 1, and 2 times k plus 1 plus 1. So we've now shown that it's true, the formula is true for n equal to k plus 1, assuming true for n equal to k. Now we need to put a statement in now that ties these two ideas together. So it's therefore true for n equal to 1 and true for n equal to k plus 1 if true for n equal to k, and those two things imply that it's true for all values of n. So quite an important statement at the end. Right, in terms of the marking for this, I can see that there were a total of 6 marks. It's a B1 mark, so no method needed to show the truth of n equal to 1. Then M1, and then a further method mark for starting off the inductive process. Pick up the first A mark once you've got down to factorizing the quadratic, and then a further M mark for factorizing it in the correct way here, and finally an A mark for this statement tying everything together. This is given as a correct solution only, CSO mark. So you have to have gone through the process without making any errors to pick up that final mark. A total of 6 marks. Right, in part B of the question we're asked to use the standard formulae for r and r squared to show that sigma r plus 2 times r plus 3 is given by 1/3 n squared plus an plus b. So again, fairly standard sort of procedure here. We start off by multiplying out the r plus 2, r plus 3. So the sum from 1 up to n of that must be the sum of r squared from 1 up to n plus 5 times the sum from r equals 1 to n of r, and then plus the sum from 1 equals 1 to n of 6. Now I've written it like that on purpose to remind me that it's not just plus 6 at the end here, but it's 6 every time we've got the summation. So now we can substitute the standard formulae. Sigma r squared is 1/6 n plus 1 2n plus 1, and then sigma r, so it's 1/5 multiplied by 1/2 n plus 1, and finally 6n at the end. Those can be factorized. We take out, as always, the largest factor we can. Always take out the fraction, so 1/6 and n, and then look at what's left inside the bracket. Well, the first term is n plus 1 and 2n plus 1. We've taken out 1/6, so think about this in 6. 5 over 2 is 15 over 6. So we're left with 15. The n has gone, and then n plus 1. And then again we've taken 1/6 out. 6 is 36 sixths, so this is plus 36 at the end. If you multiply that out, then the quadratic is 2n squared plus 18n plus 52. That we can take out a factor of 2, so that will cancel with the 1/6 to give you 1/3 n, and inside the bracket we're left with n squared plus 9n plus 26. Or in other words, we've achieved our goal where a is equal to 9 and b is equal to 26. The marking for this part of the question, there was a method mark for this first statement here, factorize or arranging it in terms of sigma r squared and sigma r. A B mark for that 6n, regardless of any sort of method, and then an A mark for the rest of the expression. A method mark for factorizing out the 1/6 n, and then an A mark for the final answer, whether or not you actually stated a equals 9 or b equals to 26, just this final answer with the quadratic correct. So there we are, a total of 5 marks in that part of the question. The final part of the question uses that answer that we've just achieved to ask us to find the sum from r equals n plus 1 up to 2n. Now in general it doesn't matter what the function is, so if I just call it a function of r for a minute, then if we're going from n plus 1 up to 2n, we have to go from 1 up to 2n and subtract from that the sum from 1 up to n of the function. Or in other words, we're just simply going to substitute the value 2n into this formula and then subtract the formula with n substituted into it. So it's 1/3, and then substituting 2n, so 2n, and then in a bracket 7 multiplied by I beg your pardon, not 7 times, so we're going into this top one here. So it's just 2n all squared plus 9, which was the value of a, times 2n plus 26, which was the value of b. And then we're subtracting from that 1/3 n squared plus 9n plus 26. We need to factorize or work out what that is. There's nothing really to take out as factors. We simply need to multiply out the brackets 1/3 times we've got 2n in the bracket, 4n squared plus 18n plus 26, and then this second bracket, just leave it as it is for the moment, n squared plus 9n plus 26 rather. Okay, now we can factorize out a value of 1/3 n and see what we've got left inside. So we're going to have 2 times this first bracket, so it's going to be 8n squared, and then minus an n squared from the second bracket, so that's the 7n squared. If we look at the n term, 2 times 18 is 36, and take away 9, so that's a total of 27n. And finally, looking at the number term, 2 times 26, 52, take away 26 from the second one, leaves us with 26. So again, we've achieved the aim, the result that's been stated in the question. 3 marks for this part of the question. There was a method mark for realizing how to do it in the first place, and an A mark for writing out that statement, and finally another A mark for getting to the final answer. Again, correct solution only. So 3 marks in that part of the question. Right, that completes that question. Others and questions for other modules can be found at www.furthermaths.org.uk.